All right, we've talked about the cast rule, and the cast rule is now something that's part of our toolbox. And as you see on this page, I've already got the special triangle sketch that we talked about earlier. So you need to make sure you have this on your cheat sheet, and this is going to be used over and over and over again. So determine the exact value of trig ratios. We're going to start off with some easier ones and move to more challenging. You're always going to draw the cast diagram for yourself. All right, that is a must off the start. So here's the cast in the 4 quadrants. The first angle I'm dealing with is 60 degrees. All right, so 60 degrees. In that quadrant, cos 60, and I know this is from the previous day, cos of 60, oh sorry, it starts with sine, of course. Sine of 60, cos of 60, tan of 60. So starting with something you're comfortable with. In that quadrant, the A indicates that all ratios will be positive. So that means I know every ratio is going to be positive. Now I'm going over to my 60-degree angle. So I'm going to use this triangle, and specifically, here's my reference angle to build the 3 ratios. So that's my reference angle. I have opposite, adjacent, and hypotenuse. So sine is opposite over a hypotenuse, so it will be root 3 over 2. Cos of 60 is adjacent over hypotenuse, so it's 1/2. And tan of 60 is opposite over adjacent, so root 3. All right. Where it becomes, or where it changes for you now, so that was previous lesson on exact value. Where it changes for you is now that we're leaving that first quadrant. So again, cast rule. According to the cast rule, 120 degrees is between 90 and 180. So that means that my terminal arm is over here. So there's 120 degrees. Okay? This is where it gets a little bit interesting. So sine of 120, cos of 120, tan of 120 is equal to, well, in that quadrant, only the sine function is positive. So that means my ratios will be positive and the rest are going to be negative. But now you're looking and you're saying to yourself, I don't have a 120-degree triangle over here. There is no 120-degree triangle. Very true. But we know that the distance on the other side of this terminal arm from 120 to 180 is only 60 degrees away. So what we find is we end up using the 60-degree triangle because there's a symmetry relationship here. All right? The 60-degree angle and the 120-degree angle are related from symmetry. All right? And the symmetry comes if we look over at this diagram here. If I was to do a mirror reflection of this one, that would be 60 degrees. And then I know that if I go from here to here, it's 120. So the triangle that we really looked at here has been constructed over here. So it's called a related angle. So really, we are looking at the 60-degree angle. So knowing that, it's the exact same as the first answer, except the signs changed. It's still a root 3 over 2, 1/2, root 3. But the signs have changed because they're in quadrant 2. Okay, so let's talk a little bit more about these related angles. So if you look at example 3, again, you start, and you're going to do this for every question. And I'm going to get some people who are going to be lazy and try to do it without, and you're going to make mistakes. 330 degrees. 330 degrees is between 270 and 360. So it's in quadrant 4. So I'm going to draw my terminal arm in quadrant 4. So this is 330 degrees. Okay, so in quadrant 4, I am looking at sine of 330, cos of 330, and tan of 330. All right, what are the values going to be in that quadrant, or what will the ratios turn out to be? Well, according to cast, only the cosine ratio will be positive. So this one will be positive, so the other two are going to be negative. Now, there is no 330-degree triangle, all right? There is no triangle that has 330 degrees. we need to find that related angle. A related angle is always with the x-axis. So if it's 330 degrees from here to here, that means that there are 30 degrees remaining, and that is the angle that we are going to use. All right, so for exact value, you will be dealing with angles that are either 30, 45, or 60, or they will be 30, 45, or 60 away from the x-axis. Okay, so if we're going to use the 30-degree triangle, that means I have to go over here and I got to readjust. Here's my reference angle. So this becomes opposite. So I'm using the red now. Adjacent, and that's still hypotenuse. So sine of 30, opposite over hypotenuse. So negative 1/2. And you can check with the calculator. Sine of 330 will be negative 0.5. Cos of 330 will be adjacent over hypotenuse. So root 3 over 2. And tan of 330, opposite over adjacent, 1 over root 3. Okay? So that's all we're doing on this page is we're practicing writing out the 3 trig ratios. All right? Okay. Sine theta equals negative 150 degrees. Negative 150 degrees. So, again, I start with cast. And negative 150, so that means I'm going to rotate in the opposite direction. So negative 150, so this would be negative 90, negative 180. So that means that 150 falls in here, or negative 150. So I'm going to be in quadrant 3. Here's the negative 150 degrees. So I want to find the exact value. I'm just using a bracket because of the negative sign. I don't want it to make it look like sine subtract 150. And tan of negative 150 equals, in that quadrant, cast tells me that only the tan function is positive, which means that all other functions are in fact negative. What is the angle that it makes with the x-axis? Well, here it is right here. I know I've gone 150. I know if I go all the way, it's 180. So that means I need to go 30 more degrees to get there. And that's the angle that we're going to use. It's going to be 30 degrees. So I'm going to be using my red notation that I have going over here. So sine of negative 150. Sine is opposite over hypotenuse. So it'll be negative 1/2. Cos of negative 150, adjacent over hypotenuse. Root 3 over 2. Tan of negative 150. And again, you can check the calculator. It'll be positive 1 over root 3. All right. So there is all 3 trig ratios for a given angle. All right. So the homework starts off just doing exactly that. And what I want to do now is the second part of the homework that you're going to run into now. Determine the exact value. So now I can throw a couple things at you. So the example here. So now with this first example, it looks very, very similar to your previous day's homework. All right, from the printout, exact value of triangles. So that being said, the difference is now I'm going around 360 degrees. So off to the side, to answer number 1, I am going to need my cast rule, and it's going to be used 3 times. So this time we can be a little bit more efficient. And I'm also going to need my 2 special triangles to go through this problem. So you treat it one at a time. All right. So sine of 135. So 135 degrees. That will be between 90 and 180. So that means that my terminal arm is going to be over here. So there is 135 degrees. While I'm here, let's talk about how much more is required to get me to the x-axis. Well, if it's exact value, I'm going to mark this on a test. Exact value means no decimals. Okay, so no decimals means that you know you're going to be working with exact value. So you're using your triangle. So it has to be either 30, 45, or 60 to get you there. And it turns out it is going to be 45 degrees. In that quadrant, only sine is positive. So that means that sine of 135, when I replace it with a fraction, it will be a positive fraction. And it's going to be linked to the 45 degrees. Sine of a 45-degree triangle, opposite over hypotenuse, be 1 over root 2. Now I'm on to the cos function. All right, onto the cos function, 150 degrees. 150 degrees also falls in quadrant number 2. So I'm going to go to a red pen here for the new terminal arm. Hey, I guess 150, it's actually going to look like it goes a little bit further. So 150 is over here somewhere. So in red, that's 150 degrees. How much is left to get me to the x-axis? Well, to get to 180, it'll have to be 30 degrees. So now I'm using the 30-degree angle, all right, in order to solve. In quadrant 2, we already talked about this, sine is positive. So that means when I replace cos of 150 with the fraction, it will be a negative value. Cos of 30 degrees is adjacent over hypotenuse, root 3 over 2, and that's done. Now we deal with the tan equation. So tan of negative 210, negative 210, we are going around in the opposite direction, and of course it has to be in that quadrant just to make things that much more messier. So we know that 210, it's actually going to rotate all the way over here, and it's actually going to be on that red line. All right, so negative 210, because that is 30 degrees from the x-axis. Not a great example to start off with. So in that quadrant, only sine is positive. So that means the tan ratio will be negative. I've already indicated I'm using the 30-degree angle. So tan of 30 degrees, opposite over adjacent, is 1 over root 3. That's the hard part. Multiply across the top. So you'd have 1 times a negative, a positive times a negative times a negative. So we're going to end up with a positive result. On top, it'll be root 3. On the bottom, it'll be 2 times root 3 times root 2. The root 3's, they will cancel each other out. So your final answer is 1 over 2 root 2. All right, and if you didn't do that reduction, believe me, by that point, I'll be a pretty happy teacher that you got that far. So I'm not overly concerned if you didn't do the reduction. All right, one last quick example with this, just to follow it through one more time, and then I'll let you go. Okay, so just finishing this one up. So here's my cast drawing. Looking at the first trig function, it's sine 330. 330 degrees will be in quadrant 4. So that means it's going to be down here. So there's the 330. Now 330 degrees, that means I am 30 degrees away from making a full circle, so 360. So that tells me I am going to be using my 60-degree angle. Whoops, wrong one here. Oh, just escape out. So there's the 60 degrees. So that one we're going to be using. So I'll do it in green, opposite, adjacent, and hypotenuse. So in that quadrant, only cos is positive. So that means the first fraction will be a negative fraction. And the cos of 30 degrees, which is in red over here, or sorry, sine. Sine is opposite over the hypotenuse, so it'll be 1/2. The cos fraction, cos of 210. 210 is between 180 and 270. So that means it will be in quadrant 3. So that's my 210, which means that I am 30 degrees away from the x-axis. 180 plus 30 is 210. I know that in this quadrant, only tan is positive, so this fraction will be negative. Cos of 30 degrees, root 3 over 2. And then our last one, tan 120. 120 is between 90 and 180. So that means I will be in this quadrant. There's the 120. I am 60 degrees away from the x-axis. In that quadrant, only sine is positive. So that means my tan function will be a negative. I'm using 60 degrees. Tan of 60 is root 3 over 1. And there we go. All three fractions are negative, so a negative times a negative times a negative is negative. Across the top, root 3 times root 3, just multiplying itself, it turns out it's going to be just 3. And on the bottom is 4, so we end up with negative 3/4. Okay. So the homework is listed. It's a bit on the website, plus you have to print out a handout. Good luck.